Okay, so for question 1, solutions that contain ions conduct electricity, and the more ions there are, the better they are at conducting electricity. So if I look at the 2 examples I gave us, I said 1 molar H2SO4 and 1 molar H2S, or first one's sulfuric acid, the next one's hydrosulfuric acid, if you kind of remember the naming part. So we need to decide which of those solutions would have the most ions. And they're both the same concentration, and both can get rid of up to 2 hydrogens, but there's something we need to remember, and that is what are the identities of the strong acids. So there's 7 strong acids. You want to be trying to memorize those. And sulfuric acid is a strong acid, whereas hydrosulfuric acid is not a strong acid. So this one is a strong acid. Kind of what we remember about strong acids is they break up completely, whereas weak acids, anything that's not one of the 7 strong acids, but anyway, weak acids, they only break up partially, because really there's an equilibrium where they break up and then they come back together, and they break up and they join back together. So this is a strong acid. Every single acid molecule in there should break up. That is not the case of this one, and so the answer would be 1 molar sulfuric acid. So totally did not mean to write on my next problem, so I'm going to see if I can erase it. I can. Okay, so anyway, first one, the answer was A. Okay, so for the next one, we're writing the ionization equations. And the ionization equation is just how it breaks up to become ions, okay? And there's 2 ways to write an ionization equation for an acid. That's not the case for bases. There's actually only 1 way for bases, but for acids, there's 2 ways. One thing we can do is we can just write the formula for the acid itself as the only reactant. Then we write our equilibrium arrows, and I should have mentioned this before, I'm sorry. HOCl, HCN, neither of those are strong acids, so they're both going to be equilibrium equations when we write them. So anyway, HOCl is my only reactant, and then acids, well, they give off protons, so it'd be H plus and OCl minus, okay? Now, there is another way to write this, like I referred to earlier, so I'm going to say or. The other thing we can do is we can put HOCl and water as our reactants, because really the acid only is going to break up in water. If I have HOCl in a glass container, no access to water, it stays as the molecule. But once I put it in water, that's when it can donate protons. So I can write HOCl plus H2O as my reactants, and then it's going to donate that H plus, that's what acids do. When it donates it to water, it gets H3O plus, because the water added an H plus, and OCl minus, okay? So you can do this either way. This is a shortcut way. A lot of chemistry people like shortcuts, I think. This is how I usually write it. But it's not really accurate, because the HOCl is not acting all on its own. But people can write it this way because everybody knows that it's not really accurate. Now you know too. They know that really it's interacting with water and giving the hydrogen to water, okay? Okay, so now I'm going to do the same thing for B. I'm going to pause this and do it. So if you still need to do it, hopefully you've already done it, but if you still need to do that, do it, pause it also, and then come back. Okay, so there's my answer. Again, there's 2 totally correct ways to write this. This is more accurate, actually, but this is a perfectly acceptable shortcut. Another thing, it would be better if I wrote aqueous behind all of these things, except for water, which would get liquid. I just don't have room to do that with the way I use the stylus and everything on this video. So that would be better. I'm not going to do it right now. Now I am actually going to add something here, and I am going to write in how we would write the equation for the ionization equation for the breakup of a strong acid. And so I'm going to use HCl. That's one of the ones I want you to memorize as a strong acid. And I'm going to do the shortcut version, and just to be good about it, I'm actually going to put in the states, okay? So since HCl is strong, we know strong acids break up completely. It's only going to get a one direction arrow. Whereas if I look back at these weak acid ones, I was doing equilibrium arrows. But other than that, it's all the same. It's going to give off its hydrogen, and then we're going to have whatever the remainder is. And again, this time I put states just to be good. So hopefully that makes sense. Okay, so for the next part, number 3, it says, which of the following acids is stronger? Well, an acid is strong, actually strong, when it breaks up completely. So when we look at weak acids, the stronger one is the one that breaks up most. And with acids, weak acids, we're dealing with really small values of K. Okay, so you'll see like 10 to the negative 8, 10 to the negative 10, 10 to the negative 11, whatever. So it's barely breaking up. And since we're dealing with 10 to the negative exponents, you have to be really careful to remember which thing is actually bigger. So 3.1 times 10 to the negative 8 is actually a bigger number than 4.9 times 10 to the negative 10. So for the stronger acid, our stronger acid is going to be this one. And then the next question says, which of the following acids has a greater concentration of the non-ionized acid molecule? Well, that means not broken up, or the whole acid molecule. So what we're really looking for is the weaker acid here. And I just said in the previous question that HOCl was the stronger acid, so HCN is going to be the weaker acid. It's going to have the one with more not broken up, non-ionized acid molecules. Then the next question says, which of the following bases is stronger? Well, remember, Bronsted-Lowry acid and its conjugate base have kind of an inverse relationship. The stronger the acid, the weaker the base. So if hypochlorous acid, or HOCl, is the stronger acid, then the base of HCN is going to be the stronger base. And so when you're thinking that through, you always want to start with, what do I know about the acid that's stronger? So stronger acid has a weaker base. If I'm looking for the stronger base, I need to go back to the weaker acid. And the last question, 6, says, which of the following statements is true? So now we're looking at stronger, and that means, does it do the acid or base thing better or worse? Okay. And then more concentrated, and that has to do with how much stuff is dissolved. So if I compare sodium hydroxide and silver hydroxide, well, I also want you to be memorizing which bases are strong, and there are going to be others that we're not going to talk about, but for the most part, it's going to be the alkali metal hydroxides, okay? And so sodium hydroxide is an alkali metal hydroxide. Silver hydroxide is not. So this is strong, this is not, it's weak. So we know that sodium hydroxide is stronger, so I can get rid of the other two statements. And then more concentrated. That is what has, referring to which one has more dissolved. So I've got 1 molar versus 2 molar. 2 molar has more things dissolved, has 2 moles of it dissolved for every liter. And so the answer would be B, because 2 molar contains more things than 1 molar.